For M1 and M2, I was in charge of the entity and archetype portion of the ECS, including the entity tree for hierarchical representation, the entire properties and reflection system, and part of the serialization, almost the whole editor, except for the game/scene viewport and the profiler, and part of the UI system, including the snapping and auto-alignment of UI elements. From M3 onwards, I worked solely on programming the game logic in C#, including the entire player and flying enemy classes and almost all of the particle effects. As the game got massively overhauled in M5, I had to rewrite or deprecate a lot of my previous code, such as the player abilities and UI. However, I won't be going through what I did for the gameplay, as it is less technically involved than my C++ code. This is our entity manager class. Our entities are stored over here as a map of ID to metadata. So what's inside this entity struct is the name of the entity for the editor, the archetype if there's any, the parent ID if there's any, the signature which I will get into later, the entity node which is a pointer to the node in the entity tree which I will also talk about later, whether it is hidden, so like things like archetypes will be hidden from the editor because we don't want users to be messing with those, and whether it is a scene object, which I will not go through because it's not done by me. This is for the scene referencing. So the entity manager manages both the entities as well as all of their component data, and it's thus bloated with a lot of functions, as you can see over here. Normally, most of these functions will also be in a factory class or something, but over here I just put everything in the entity manager. It also has a unique feature to be able to query components using a string or ID. I think I removed the string version, so it's just using an ID instead of the usual templated version that I have over here. Yeah, so this has the benefit of being able to making your components loopable, since you can just iterate the ID in a for loop and query component by component if you like don't know what components the object has. So how did I achieve this? As I can't create a vector of templated types to store all of the component lists, I mean I can't simply just change this to like a C or something, where C is a type name. So I made the components inherit from this component. I mean all of the components inherit from this base struct, and so that I can have vectors of callbacks which return that base class. So as you can see over here, this is like a vector containing all get components from all component list. So basically how it works is that we have a component list over here, this created by somebody else, which contains an object pool for all of the components which are manually allocated. So so each component has its own list, and whenever a component is instantiated, you can see like over here in the constructor, it will register the component with the entity manager. So what this function does is that it will just push back the various functions into the various vectors of the entity manager, and then when you call like the runtime version of like get component, add component, or etc., it will just it will just call that function in the vector. And for get component, of course, it will return a component instead of the actual type of the component, instead of like transform component or something. So what you need to do is that you need to like dynamic cast. I think I have an example in this file. Yeah, you need to dynamic cast it. Dynamic cast its address into the respective like component that you want. So of course this is not very good. Like if you know the type, if you know like the type you're getting beforehand, it's more recommended to just call the templated version of that component. But this is useful in like a for loop where you want to, I think, I'm not sure whether it's, I think this, for example in a for loop where you just want to loop over all the components an entity has, and you don't want to like manually check, oh, does it have transform component, then call transform component, does it have rigid body component, etc. Yeah. So the entity manager also has like templated and non-templated versions to check what components an entity has. So this is like this has any component. So this is a templated version. So what the templated version first does is that it generates a signature, and basically what the signature is okay, let me just go to this function. You can see that it uses it unwraps the templated the variadic arguments using a full expression, so that it's the code is much cleaner. It's just one line to generate the signature. So what a signature is simply a 64-bit bit set that is set to 1 for components that the entity has and 0 otherwise. So the index of this bit corresponds to the component ID over here. So you can simply use the same number to get the component as well as use it for the signature, because the signature requires a bit set and I need a number for the bit set to check which index like the component corresponds to. Then after you generate the signature, where was I? Over here, then you can check, for example, has any components, which returns true if as long as one component in this entity ID matches the as long as this entity has at least one component in here. And what this function does, it just does all this function does a bitwise check to see whether the bits match. So it's quite fast. So for the archetypes which are also managed by the entity system, they are essentially entities that do not get updated. When the engine loads, all archetypes are loaded from file and stored in memory. When an entity is created, say from a scene file, the entity's properties are first copied from the archetype. So as you can see over here, the entity is first created, a blank entity is created, and then it is populated. If it has an archetype, it is populated with the archetype's data first. And next, it will then be its properties will then be overwritten or added on. So for example, if the archetype doesn't have the component that the entity also has, then the component will be added. Else, if the archetype has some property which is different and the entity has the same property, the entity's properties will override the entity's properties which are stored in the scene file will override those in the archetype file. So as you can see, this whole chunk is doing just that. So this helps compress the scene file, as the data of commonly used archetypes need not be repeated and can be extracted into a separate file, in this case the archetype file. So why not I just show you the example. So in our sandbox.scene, you can see that this is a grenade object. It has basically this is the scene file, and it has like no data to actually create the grenade, because you can see that all the components are null. So the things that start the hashtag is actually like the metadata, whereas everything else is the component data. So if you take a look at what's inside grenade.arch, you can see why we do not need to store this data in the scene itself. So this is where all the data is required to just create the grenade is stored. And actually, if we change like the grenade, so for example, I think you can see that transform, the position is the only variable that is, or is the only property that is stored in the scene file. However, if I change this, because right now if you see all the other properties, you can see that it's copying from the archetype. However, the only thing that is not is the position. However, if we check this also as copy from archetype and I save, you realize that it returns to like the position set in the archetype, which is over here. Yeah. And if I then save this scene, you can see now that that the transform is now null, because it doesn't need to store that new position anymore. So likewise, if I then change the position, you can see that this property is automatically set to false. Yeah, so this applies with anything. Let's say if I just change some lighting, maybe like the light intensity, and I just save this, you can see that now it has a light intensity and a transform saved in the scene file. To create a hierarchical structure for entities to be neatly displayed in the editor, I used a modified binary tree where nodes to the right, so for example 674, 299, 083 and 150, they are all in the same level, whereas nodes to the left are the child of the current node. So for example, 674 has 999 below it, and the child of 999 is 744, whereas 299 is on the same level, and then the child of 299 is 301, and 301 is 301, 040 and 344. They are all three in the same level, and so on and so forth. So in hindsight, I probably could have used a vector. So over here you can see that I have a unique pointer for the root. I probably could have used a vector in each entity storing the children and looping over them recursively with similar space and time complexities, but I have no idea why I decided to come up with this idea. I mean, it works, but it's just a bit overkill. In hindsight, I probably should also not have used unique pointers, as they made my code way more verbose than it needs to, and is redundant anyway as I was manually managing memory. So I tried to make my system as versatile and flexible as possible by including any functionality a user might need and allowing users to iterate through the tree in both directions and write their own filter functions. So as you can see, I have a for each and for each reversed, which just iterates through the tree in using depth first search. So I also have a filter function where you can choose not to enter the node and thus any children if you return true. So for normally for recursive functions, so let's go to this function. Normally it's written in a recursive way. However, I made it iterative because I want to avoid stack overflow if my tree has like more than 40 levels or something. I'm not sure about the exact number, but I know I think MSVC does like throw a stack overflow error if you are too deeply nested, and I think the limit is around 40. It's normally not an issue with binary trees that are automatically balanced, but but my tree is not meant to be balanced because it's the whole point is for the users to customize it however they want. So my function also keeps track of the path taken, including the number of times the function returned from a visited node, i.e. went up the tree, as you can see in this up count over here, which is incremented every time the current node is the previous to the current node is from an up direction. So that systems like the serializer and hierarchy panel will have information like the entity to ignore showing in the panel, or the number of times to call I'm-GUI tree pop. So what I mean by this is that I need to call tree west tree pop. Okay, I need to call tree pop every time I'm in, for every level I am in. But then I cannot call it directly after I enter a level. I need to call it at the end once I exit from all of the levels, and I don't know how many levels I'm in if I do not have like the number of times that the node went, the node gone up the tree. So and then the second use case is in over here. If I, for example, I don't want to show like the children if this thing is closed, so I need to check whether like this is the current, if for example if this is the current entity and like these are the children, I want to check whether I am at this current entity. So I can do that by checking whether the previous direction, this direction, is left, because if it's right, it means that it is not the first thing in the list. Speaking of the hierarchy panel, I created a fully featured hierarchy that allows for group selection with shift. So for example, you can press and hold shift and select all of these entities at once. You can do that for any number of entities, and do keep in mind that even though it's not shown here, entities that are inside the parent, all the children entities that are inside the parent are also selected. And I don't know, this might be bad UI or something, but I created this feature before the hierarchical viewing. If you don't want to select all the entities, you can also press Ctrl instead to select them one by one. Now this ensures that if I click on this, only the parent is selected and not its children. And over here in the inspector, you can see the components that are shared. Okay, so now you can also drag and drop entities into one another to make them a parent of one another here. For example, I can drag this spaceship, the broken spaceship. Now broken spaceship will be the parent, and I can also drag, let's say, like a grenade into spaceship and a hand light into a spaceship too. And then you can see that now spaceship contains two other entities. So over here you see three icons. If I click on this, they will all be hidden because this controls the visibility. And as you can see, the visibility propagates, all of these except, this and this propagates downwards. And what is this bell? That changes that sets whether the entity is active or not. So inactive entities will not be rendered during the scene. When the scene is playing, which it isn't right now. And this is to dynamically link objects together. So you notice this is different because you need to check all of the parent as well as the child's properties. So if I do that, and you can see that if I move the parent, the child will move, but if I move the child, the parent will not follow. So you can also like make the child orbit the parent. So for example, if I rotate this, you can see that the child is orbiting the parent instead of simply following the parent's rotation. I can do the same in like all three axes, but I think due to gimbal lock, some of them, yeah, as you can see, it's not very inaccurate. It's not supposed to go back and forth, but this is a problem that is beyond me. And next is also the copy and paste. So if I want to copy and paste this, I can just press Ctrl C, and if I want to paste it, I have to first select the parent that I want to paste it in. So for example, sandbox.scene, and I can choose whether to paste entities with the same ID or not. If of course, if I choose paste entities with the same ID, you'll get a warning that the ID already exists and it will not be pasted. However, if I just press Ctrl V, which by default uses the one without the same IDs, you can see that the new entities are pasted, and there's some issue with the rendering. It's not the entity properties issue, because you can see that even though for some reason the spaceship is really huge, but they have the exact same scale and the exact same mesh. So yeah, this is also not an issue for me to fix, and honestly, I didn't even know this was an issue until now. Anyway, how the copying works is that you can see that it also copies, even though I only selected the parent, it also copies all of the children. And if I select the children then the parent, it will also copy correctly. So I can just copy this two. Yeah, it says copy 4 entities because the children is not copied twice, and I can paste it the same way. I'll get the exact same entities over here. So how this works is that if multiple entities are selected, okay, let's go to the copy function first. I think, yeah, this is the copy function. If multiple entities are selected, the function will add them in the order of selection as well as their children to the clipboard. But if a child was already added previously, it will be recursively removed and then re-added to ensure that its parent will come first in the clipboard. Meanwhile, the paste function maintains a map of old to new IDs over here if the user chooses to paste with a different ID. Since it is guaranteed that a parent will be encountered in the clipboard before their children, its old and new IDs will be added to the map for their children to refer to and update entity references in the components. If an entity with a parent, or parents if it is deeply nested, is added to the clipboard without its parent, it will simply be pasted as if it didn't have a parent. So what this means is that if I just copy this handlight and grenade without copying the spaceship and just paste it, it will not paste with the spaceship. It will just paste with just these two standalone items. So as for the references, what I mean is that if I let's say grenade references broken spaceship in like a script or something, because I think, okay, let's say the explosion UID, let's make it reference the broken spaceship, and let's just change this name. Okay, wait, let me just spawn a copy of this entity first and paste. And now now you can see that this broken, where is it? This grenade. Yeah, this grenade is referencing broken spaceship. And let me change the name to like 1, 2, 3. And now when I look at the grenade, it should be, it should say broken spaceship 1, 2, 3. Whereas this grenade that was copied, it will still say broken spaceship because it's referring to its own broken spaceship. For example, if I change this to 4, 5, 6, you can more clearly see this effect over here. Yeah, it says 4, 5, 6. So this is done using the code over here, where it just recursively goes into each component, checks whether the component has a property that has like a UID type, and then if it does, recursively for the map and vector, and then it just checks whether it has like the UID type, and then just replaces the OIDs with the new IDs. To loop over properties in a component, for example, I think you have seen just now in Entity Manager. I don't think it was this function, but it does something similar anyway. So you can see that getComponent.getVars returns something iterable, as opposed to you having to manually go and set each property in each component, which is going to take up a lot of lines of code. So basically what this function does, it just updates the archetype whenever a user saves it in the archetype editor. But anyway, back to the components. So each component contains this var container, and what this var container is basically a map of string. This string is the variable name. Variable in our case refers to the properties in the components, and as well as the var object. So this string refers to the name of the variable, but as you can see in this var object, it also contains this name, and this is the name that's actually shown in the editor. For example, if I click on this, this is the name like pause rod scale that I can edit over here to like position. Whereas this name is set by something like, let's say, in the transform component. Yeah, you can see that this name is set over here, which just takes the name of the variable, of the actual variable itself. So make var is just a macro to add var with the same name. And yeah, so it contains the var object also contains other metadata. For example, all these that you can read over here. And that's a bit long. And also, more importantly, it contains a custom pointer, this any pointer, which can point to a fixed set of data types and at the same time know its underlying type using std variant. So why I need it to be a pointer is because I need to be able to edit the actual, because this just points to like the actual properties in the component, and I need something like update archetypes to actually change the value and not just read from it. So you can see the types over here, which is looks a bit messy, but I think this is way better than having a lot of repeated code. And this is technically not true reflection, which can only be achieved with code generation, as whenever a new data type needs to be reflected, it has to be added to this set. However, it does allow us to write very generic code to copy or move data around, as you have seen earlier. And for the inspector, I only needed to write the logic to display each data type once. So instead of having like the inspector, instead of having like a function instead of having like to write a specific like UI for each property or each component, it can simply call this function, and depending on the data type, for example, for Boolean, it will just display a checkbox. So any object, if you pass an object that is a Boolean, it will just render a checkbox, which is quite convenient. As you can see in our inspector, I only need to call this modify data, and you can see that the code is not is kind of clean. Yeah. So speaking of the inspector, so let's go back to the editor. This inspector can also apply changes intelligently across entities if more than one is selected. So earlier I said how we can multi-select. So for example, if I select like let's say this broken spaceship and something invisible, like let's say this Ravy Rock and this broken spaceship. So these two entities are selected. So you can see if I change their position, or if I can even use it with the gizmos, the positions are not set to one another. Instead, only the difference is applied to the other entity, or however many entities I select. I can just select, like for example, I can just select this entire walkables and just shift them all at once, which is very, very convenient. I can also undo them all at once. So I created an undo/redo system that can undo/redo changes in the properties, components, and entities. So I'll give a quick demo by going over the undo and redoing of entities. So for example, I can select these entities and delete them, and you'll notice that a lot of entities have been deleted, and that's because they were recursively deleted. And if I undo them, you'll notice that they are all added back correctly, just that the order might be a bit different, but you can simply move them up by using this button. You can also undo and redo components. So for example, if I select all of these, and keep in mind that this already has this entity specifically has an animation component. So I'll add an animation component to all of them now. And what you notice is that I'm able to do so. But if I undo that, right, you notice that all the animation for this entity has been deleted, but the animation component in this one has not, because it originally already had an animation component, so it wasn't added. Next, you can also undo and redo properties. So a quick demo will be just to modify the transform using the gizmos. I mean, it also works if you just use the sliders here. And if I undo them, you can see that they are popped from the stack and added into the redo stack instead. So I can also redo them. So how it works is that it uses a custom circular array, as you can see over. Yeah, it's just an array. It's nothing exciting. To store user actions sequentially and efficiently. So when it reaches like 256, you just loop over and overwrite any existing data so that it doesn't use too much data, because it actually stores a snapshot of like for example, the component data of whatever, or the property data of whatever property that you edited. So it can be a bit expensive. So when Control Z or Y is pressed, I think I'll show the code. If I remember, it was it was over here. So pop undo is called whenever you press Control Z. So when you press Control Z, first the current state of the entity or component or property is captured over here in the reinit. Before the topmost action is popped from the stack and executed and then added into the other array with the captured state. So each action actually inherits from a base action class, which requires a struct containing a copy of its own data. So what this means is that, for example, if we look at this modified variable, which is used to capture the modified properties, we have an extra struct over here that is basically the exact same as all the data it has, but this is to store its own data for the opposite action. So for example, if I change a property, it would store the values before it got changed when I press like undo or redo. So it also requires the implementation of these 5 functions. Execute is the main body of the action. Reset, which why not I just show an example. Let's show this for example. So reset, what it does is that it just resets its own data, and then reinit to execute, which is this function. It does the same thing but for the copy instead, the copy of the data, and reinit, which captures the current state. So if I can, here reinit captures the wait, this is the component one. So reinit captures the current state of the of the action before it was performed for the opposite action, and reinit info, which just updates the info for the editor to display. So for the modified variable action, so if I just search for modified variable, as you can see over here, it only captures the change when the mouse is lifted. So that means, like for example, if I slide over here, you can see in the save actions that it's not being captured. The moment I let go, then it's recorded, so that I will not like record or change every single frame and I have to press like Control Z a million times to get back to the original state. But if the user actually types like a value, for example like 1, 2, 3, you can see that it does copy like 1 and then 1, 2 and then 1, 2, 3. And if I undo, you can see that being executed, which is maybe not so like user friendly, but it's just a small issue. And then for the modify entity action, to undo deleted entities, the saved entities are added over and over again, as you can see over here, and with a factor of booleans, this one, to keep track of the added entities until no new entities were added. So entities with a non-zero parent ID whose parent is still not alive, they will not be added in the current iteration, ensuring that the parent will always be created before the child. For our editor console, we technically only needed to be able to display logs to be searched, filtered, and collapsed, but I got carried away and made a tokenizer and a parser to accept commands too, but it didn't make many commands as we had no use for them. So I'll just show you by typing help, and you can see that we only have just 3 functions. Let me just clear the console first, and you can also press this to I think that clears that too. Okay, so you can press help, and technically if I press this again, you can see help being labeled there, and oops. Okay, anyway, yeah, so clears the console, and the only other command we have with parameters is log. And so what this does is that if I just type log without anything like hello, you can see that it's missing the first parameter because this -m parameter is necessary. So for example, I have to type -m, which stands for message and then hello world. And oh yeah, okay, pressing enter also works. And yeah, then you can see that it prints out hello world to the console with and defaults to like the information, it defaults to the info log channel. So I can actually specify like a different I can specify it to log to a different channel by using the -c parameter. Let's say like error, I can just use E for short, and it will print to the error. And you can use you can actually do so with like any number of like letters, like say like WAR for warning, and it will print to the warning channel. And you can do this in any order also. So for example, I can, instead of like -c war, I can put like -c, let's say D for debug, and then enter, and you can see that it still works. And also, if you let's say like type this wrongly, let's say there's nothing that starts with O, so you see that it's an invalid argument. And if you let's say like do like a -d, which there's no -d, there's only -c and -m, you also have another error, which is the unknown parameter. So the way I achieved this was yeah, okay, so when you press enter or press the arrow button, it will the code will attempt to execute the input. So what in this function, in this function, it splits the input using space as the delimiter over here. If you call this function with no parameters, it just defaults to space. The first string that you enter, like log, it should be like it will check whether this is a valid command. If it's not, like let's say like PO or something, then nothing will happen. If I type it without any parameters, this will happen, missing parameters. Yep, okay, so if it's if the first one is a command, then the function will attempt to execute it. So far I only have one command which takes in parameters, as you have seen, so this is not very interesting. Let's take a look at log. Firstly, set params is called to initialize the one character parameters with empty arguments. So this param is a map of the parameter letter, because each parameter is only one character long, and to the value is, in this case, is like the argument, which is just a string or that can contain spaces. So next, parameterize is called, and in this function, you can see this function over here. It's not too long, which logs an error and returns false if the user input was invalid. Basically, parameters are supplied with a dash, as we have seen earlier, and one character after it, and all tokens between a parameter and before the next one will be the argument for that parameter. This means that unlike an actual shell like bash, parameters can appear in any order, and an argument can contain spaces, although there's a slight drawback of having to type a few more characters. For each token, in this for loop, it checks whether it begins with a dash over here, and if it does, it does some simple sanity checks, like whether the same parameter exists in the map. If the parameter is not the first token, it suggests that another character, over here, it suggests that another parameter has already been recorded previously, which would be stored in the last param variable, this one. However, if last param is the previous token, it suggests that there is no argument supplied for last param, which indicates an error. Okay, I should stop moving my mouse. Otherwise, it will merge all tokens between one past the last param and one before the current token, inclusive, into a single string into a single string with spaces intact to set as the argument for last param. This step is also done once more, as you can see over here. This one. It's done once more outside the loop for the last parameter. Lastly, all arguments, as you can see here, are trimmed of any leading or trailing spaces. So that's it for my presentation. Thank you for watching.